Yeah, so the first process under monitoring and controlling is monitor and control project work. So there, most of the things we already discussed. The inputs are the project management plan, performance reports, enterprise environmental factors, and organizational process assets. And the tools and techniques is the expert judgment, and the output is change requests, project management updates, and project document updates. One minute. Okay, so I've muted you, and maybe if there are any questions, you can type in. Now here, if you see, while doing the monitoring and controlling, sometimes we will raise a change request if you need any scope change or cost change or things like that. We may have to raise change requests. Sometimes we may update the project management plan, or while doing the monitoring and controlling, we may update any other document which we have prepared so far, including the work breakdown structure, or even the project charter, or even the statement of work. So project document updates can happen during monitoring and controlling based on the current snapshot of the project. Then the second process under monitoring and controlling is perform integrated change control. So again, here the inputs are project management plan, work performance information, change request, enterprise environmental factors, and organizational process assets. And the tools and techniques are expert judgment and change control meetings. And the output is change request status updates, project management plan updates, and project document updates. So there is, I think you are clear about these things because we have covered most of these things before. Now it is only a repetition of what we covered before. This is a workflow of a change request system. So whenever there is a change request happens, you raise a change request, and it enters the proposed change, gets into the integrated change control system, and here a CCB, we call it as a CCB or a change control board. They discuss about the value of the change, the benefit cost, the risk, and the political capital. So all these things are discussed, and based on these things, either the change gets approved or rejected. So if it is approved, sometime we'll have to update the project baselines of time, cost, and scope, and we have to update the project plan. And if it is not approved, still we should inform the stakeholders on why it is not done, and then archive the decisions, because tomorrow if some discussions happens around it, okay, this archived information will always help you. So this is a workflow for a change control system. So if it is there, you can use it during project execution and monitoring and controlling, and if it is not there, you will have to implement one. So anything that is under configuration management, that means anything which has a version number attached to it, should be managed using a change control system. So you have any queries on this? Okay. Sometimes the questions are like, who all could be the participants of the change control board or CCB? The answer is relevant stakeholders. So sometimes it is the project manager and the architect and the quality manager, customers project manager. So you can decide. So there is no standard composition to the change control board. So you can decide who all will be part of it. Then the third process under monitoring and controlling is verify scope. So here again the input side, if you see, there are the project management plan, requirements documentation, requirements traceability metrics, and validated deliverables. When we say requirements traceability metrics, during requirements collection we spoke about a quality function deployment, QFD, where we said the requirements are captured on the y-axis and the features are captured on the x-axis, and then mapped. So these are mapped to see the coverage. So that is an example of requirements traceability metrics. Requirements are mapped to features and features are mapped to the work product. So during inspection that will come in very handy to see whether everything is delivered as per the agreed upon scope. Then comes validated deliverables, so that also becomes an input, and the primary tools and techniques used here is inspection, and the outputs are accepted deliverables, change request, project document updates. So all these things becomes an output, right? This is done for all sorts of projects, right? Because now I'm constructing my house. Now whenever I'm settling the payments, before that I should do an inspection, and I should check whether everything is done as per the drawings, which is agreed upon. So if there is a deviation, I'm supposed to take action. Okay, so this is applicable to all sorts of projects, not just IT projects. Then comes the process number 4 under monitoring and controlling is again control scope. Here the input side, if you see, we have the project management plan, work performance information, requirements documentation, requirements traceability metrics, which we already discussed, and organizational process assets, if any. Then the variance analysis is used as a tool, and the outputs are work performance measurements, organizational process assets updates, change requests, project management plan updates, and project document updates. So most of the things we have already, I think it should be clear to you now, by now, because we have discussed these things somewhere before. Then comes controlling the schedule, that is process number 5 under monitoring and controlling. The input side, again, if you see, it is a project management plan, project schedule, work performance information, and organizational process assets, and the tools and techniques are performance reviews. So during earned value management, we discussed about SPI, CPI, SV, the schedule variance, and cost variance, estimated completion. So all those things will give me a snapshot of the current status of the project. So they all can be treated as examples for performance reviews or the contents of a very good performance review. And then variance analysis. The schedule variance and cost variance is an example of variance analysis. Project management software. Sometimes we'll use the MS Project or Primavera kind of thing to help us to track the variances. Resource leveling is a concept where let's say when you schedule a project, first you will come out with a schedule, and then slowly you start adding manpower or loading manpower to the schedule. And when you load it with resources, sometimes you realize that some of the resources are heavily loaded, whereas some other resources are underloaded. So some of the resources may be loaded for 15 hours per day, whereas some other resources may be loaded only for 3-4 hours per day. So that way a team cannot perform. So through trial and error, we'll ensure that everybody in the team is equally loaded to the tune of maybe 6.5 hours or 7 hours per day. So that process we call it as resource leveling. So there is no formula for that. Through trial and error, we ensure that all the resources are loaded for approximately 7 hours per day if the total working hours is 8 hours. That process we call it as resource leveling. And what if scenario analysis, instead of a particular raw material, if I use a substitute raw material, what will happen to the cost and what will happen to the quality? Or an activity, instead of completing it in the normal time, if I put more resources into it and crash it, now what will be the schedule advantage and what will be the additional cost burden? So all these things are examples of what if scenario analysis. Then adjusting leads and lags. Now if you have to achieve a milestone in a particular time, then maybe you will try to achieve it by optimizing the leads and lags. When we say leads, we are talking about parallelism among activities. When we say lags, we are talking about waiting time. Then sometimes, okay, now if to control the schedule, we'll have to do the schedule compression. For schedule compression, we spoke about, we discussed about two key tools or techniques like fast tracking and crashing. Fast tracking is all about trying to do things in parallel, which were originally scheduled sequentially. And crashing is all about putting more resources into an activity so that you can reduce the duration. So if there is a schedule variance, we may do both fast tracking and crashing, depending on your current cost performance index and schedule performance index. If the cost performance index says that cost is already you have overran the budgets, then crashing may not be possible because you don't have surplus money, and crashing will invite additional cost. Then the only thing you can do is fast tracking if your flexibility metric says that cost is not flexible. So now you may be seeing like everything is tied together because at the time of initiation and planning we spoke about flexibility metrics, which will tell us about what is flexible and what is not flexible. Is time highly flexible or moderately flexible or least flexible? Is scope highly flexible or moderately flexible or least flexible? Is cost highly flexible or moderately flexible or least flexible? So for a project where cost is least flexible and if the CPI of the project is less than 1, that means you have already exceeded the budget. In that case, okay, you cannot crash because crashing will invite additional cost, and the only solution could be substitution of a material with a cheaper material, or it could be even fast tracking. I hope you are with me because now you may be getting the connection between all these things, flexibility metrics, the cost performance index, schedule performance index, fast tracking, crashing. So everything is connected, everything is interconnected. Then comes scheduling tools. PMI is vendor neutral, so they don't talk about any particular tools. But generally speaking, the two most widely used scheduling tools are MS Project and Primavera. So most of the heavy-duty projects they use Primavera because the costing module is very robust. For IT projects and on MS Project, they generally use. And the output of control schedule is work performance measurement, organizational process assets updates, change requests, project management plan updates, and project document updates. So all these things can be outputs of control schedule. Then the next process is control costs, process number 6. So again, the input side, if we see, we are talking about a project management plan, project funding requirements, work performance information, and organizational process assets. Earned value management is the tools and techniques which we discussed and a separate video of this is also uploaded in YouTube. Then forecasting. So within the earned value management itself, we spoke about estimated completion, which is a kind of forecasting. And we even discussed about to complete performance index. So that is also a kind of a forecasting, which we discussed when we discussed about earned value management. Then performance reviews happens where you track the CPI, SPI, CV, and SP of the project, and variance analysis is nothing but this cost variance and schedule variance and all those things. And sometimes we use the project management software, because in most of these project management software has functions for earned value management as well, so you can use them. But then it needs a lot of discipline in defining your work packages, sizing your work packages, because for a small project, if you have very uh, big work packages, then the project will not show any schedule variance for a long time. Because for a 6 months project, if your work packages which runs for 2-3 months, for 2-3 months time, the project may not show schedule variance. So that is not okay. For a smaller project, the work packages should be smaller, because we discussed about this 880 rule, where smaller the project, the work packages should be towards 8 hours, and for large projects, the work package can be towards 80 hours, or it could be anything in between. So if you can follow all this rigor in your project planning, then maybe an effective implementation of earned value management is possible. Otherwise, it is not difficult, but then it calls for a lot of discipline while planning the project. Yeah, so then the outputs are work performance results, budget forecast, organizational processes, change requests, project management plan updates, and project document updates. That's fine. And the earned value part we already discussed, so I'm not discussing it now. So if you want to go through it again, please, we have those videos already uploaded, so you can go through that. Then the process number 7 is perform quality control. So here the input side is project management plan, quality metrics, quality checklists, work performance measurements, approved change requests, deliverables, organizational process assets. All these things becomes an input side, form the input side for perform quality control. And the tools and techniques are cause and effect diagrams, which we have already explained. This cause and effect diagram is also known as Ishikawa diagram or fishbone diagram. Then yesterday we discussed about control charts as well. The key thing about the control chart is customer specification limit, upper control limit, lower control limit, outliers, random costs, random costs, and there was some other name for the other time, random costs, and rule of seven we discussed. So random causes and actionable causes, rule of 7, upper control limit, lower control limit, customer specification limits, mean. So all those things we discussed. Then flow charting, we discussed about JERT. JERT is an example of flow charting. When we discussed about critical path, activity on arrow, and activity on node diagrams, we discussed about flow charting. And another terminology for given there was JERT. Then histogram, yesterday we discussed about the 80-20 principle, where you draw a histogram based on the descending order of frequency of causes. It's an example of histogram. Pareto chart, we discussed about a Pareto chart based on 80-20 principle. We already discussed about it. Then run chart, yeah. Right. That is a cumulative difference. See, the first histogram plus the second histogram will give me one data point on top of the second tower on the histogram. Right now, if when we draw something like this, here there is a histogram. This is contributing to, let's say, 50. Here there is one which is contributing to 30. Here there is one which is contributing to 10. So when I start here, it is 50. 50 plus 30 becomes 80. 80 plus 10 becomes 90. So that's how the curve goes. It is a cumulative of these things. It need not be absolute cumulative. It can be the weighted average. So it is a weighted average curve. And here, if you see, this will be the total number of defects. It is nothing but the sum of all these things. Yeah. So generally, when we were using Pareto, we never got into this cumulative chart. In that particular diagram, okay, this cumulative chart is there. Okay, so that's all. So otherwise, as you rightly said, if I have 10 causes, by looking at the histogram itself, I know which are all the 20% of the major causes contributing to 80% of the defects. So then it's very, very easy for me to take action on this segment than on whatever is here. So my corrective actions will be more focused. So that is the idea. Okay, then run chart is nothing but, okay, now that chart which is running on top of the histogram is the run chart, is the run chart. Here is an example of a run chart. Okay. Then scatter diagram is like, now during the acceptance test, it's nothing but affinity diagram. Did we discuss about it? Yeah, because if I have for module 1, module 2, if I have, let's say, 200 defects, where will I start taking action? So I have to plot those defects against those modules, and then suddenly I will see clustering of a lot of defects against a particular module. Then we say this defects has an affinity towards that particular module. So that is an example of scatter diagram as well. Okay. Then comes statistical sampling. Now let's say in a particular project, as of today we have 2,000 defects, and drawing a Pareto or doing a Pareto for 2,000 defects is not feasible, because the effort involved could be very, very high. So then what we have to do is we have to take a sample out of that 2,000, which may be 200. But that sample should be a true representation of the population. There are some statistical methods for that. And on the sample, we do all this analysis, like Ishikawa, Pareto, and all. So there is application of statistical sampling in project management. Another example of statistical sampling is all these exit polls and all. Before the election, an agency can conduct a study and then come out with predictions. So that is another application of statistical sampling, because that surveys, they are not conducting on the entire population, they are conducting on a cross section of the population, which is a replica of and it's a reflection of the entire population. Then comes inspection, that's fine, approved change request, review change request, all those things. So there's nothing to discuss there, because we have discussed these things before. Right. Quality assurance is the purest definition of quality assurance is all those things which we are doing to prevent problems from happening is quality assurance. That it could be reviews, audits, assessments. So all those things which we are doing to prevent problems from happening, that is quality assurance. Process definition, process training, all those things. Whereas anything which involves rework, that is quality control. So in IT, testing is quality control. Everything else is quality assurance. Because that is just to check, because testing is not going to add any quality to your product. It is only verification. Okay, but the right design, the right training, the right tools, all those things, the reviews, all those things will improve the quality of the product. Okay, then the next process is report performance. Again, the input side is project management plan, work performance information, work performance measurement, budget forecast, organization processes. Tools and techniques are variance analysis, forecasting methods, communication methods, reporting system. And the outputs are performance reports, organizational process assets, and change requests. Again, here we have discussed most of these things in the previous sessions. Okay, so then monitor and control risk, which is the process number 9. So here the inputs are risk register, project management plan, work performance information, and performance reports. And the tools and techniques are risk assessments, risk audits, variance and trend analysis, technical performance measurement, reserve analysis, nothing but buffers, and status meetings, the risk status meetings. Outputs are risk register updates, organizational process assets updates, change requests, project management plan updates, and project document updates. Then the process number 10 under monitoring and controlling is administer procurements. Here again, the input side is procurements documents, project management plan, contract with the subcontractors, then performance reports, approved change requests, work performance information. Tools and techniques could be contract change control system, procurement performance reviews, inspection and audits, performance reporting, payment systems, claims administration, records management system. All these things are tools and techniques. And the output is the procurement documentation, organizational process assets updates, change request, and project management plan updates. So there is nothing new here to explain. So I'm proceeding. So now next is close the project. I think we'll do this in the next session, maybe next Tuesday. We'll get into closing the project as well as we do some practice tests as well. Okay, because yeah, so I think we must call it a day, and we'll meet on next Tuesday at 2:30 p.m. Indian Standard Time.